Hello, I'm going to look now at how to draw a quadratic function graph. Now, before we start, the graph pretty much takes two shapes. If I draw an x and a y axis, let me pop it there, x and a y axis. Generally speaking, we'll find that our graph will either go like that, and these are graphs where y is equal to some positive number times x squared, like x squared, or y equals 2x squared, or a graph like that. And then there's graphs that are upside down, where they go, say, for instance, like that. And this will be a graph with something like y equals negative x squared, or negative 2x squared. So there's two basic shapes, and unlike straight line graphs, they turn around. The interesting points, if I can label them, that we need to graph them is we need to know this point, which is the y-intercept, and we need to know that these 2 points down here, which are the x-intercepts. Let's write it as x-int and x-int. The other useful point to know is where the graph turns around, which will be here, and we call this the turning point. In this case, the turning point is what we call a minimum, because it is the lowest point in the graph. This graph over here has got the same thing. It's got a y-intercept, but its turning point is probably about there, not quite on the y-intercept, and we'll call this turning point a maximum, because it's the highest point on the graph. So in this case, minimum, and then so this is a minimum, and that's a maximum. There would be the y-intercept, and there would be the x-intercepts, and as you can see, the x-intercepts and the y-intercepts are light labelled here. This type of curve is involved in things like the shape of radio antennas, satellite dishes. So that's this curve over here, and this kind of curve is the classic curve that you would get if you threw a ball into the air. Okay, let's see how to graph it in more detail on the next slide. Let's assume that the function is going to be y equals x squared take 2x take 15. Now to draw my graph, I've got to find first of all the y-intercept. The y-intercept is really easy. It's when x equals 0. So if I want to work out the y-intercept, then all I basically need to do is I need to set x equal to 0, because that's when we have the y-intercept. So I just set x equals 0. So y becomes then 0 squared minus 2 times 0 minus 5, which means y is minus 15. So y is just negative 15. An easy way to think about the y-intercept is you look at any term involving x and you know it's going to be 0. So this is going to be 0, this is going to be 0, so the only thing left over is this term over here, which is the term for the y-intercept. Let's have a look at the x-intercept. This is slightly harder. The x-intercepts occur when we have to set y equals 0 for this, so we end up with 0 equals x squared take 2x take 15. So to solve this problem, we're going to have to turn it into a quadratic equation. Or rather, it is a quadratic equation. We're going to have to factorize it. So we can write it as x minus 5 times x plus 3. If you want to know how to do that, remember what we did earlier on. I'll just write it down on the left hand side here. I can easily do it with the x method, where what things am I going to use to work out negative 15? Well, I could try 3 and -5, or -5 and 3, which is the same thing, or I could do it the other way around, and I could try 5 and -3. It turns out that the one that works is the -5 and the 3, because if we think about it, when we go and work it out, I'm going to get -5x plus 3x, and that's going to give me -2x, which is what I'm looking for my middle term. Okay, I've got two things which, when multiplied together, equals 0. So either this bit's going to be 0, or that bit's going to be 0. So if I go further down to write it down, or rather move everything further up, we just go and move things further up. What we're going to find is that either x minus 5 equals 0, which means x will be equal to 5. Oops, I don't know what's happened now. That means x equals 5, or x plus 3 equals 0. Means x will be equal to -3. So my two answers for the y intercept is x equals 5 and -3. They're my two answers. In fact, I probably need to write that better, and I might write it as, instead, 5. Just so we are a little bit clearer, I'll write it as 5 and a -3. So you know it's not a xy coordinate. Okay. Now, to work out the turning point, I'll do that on the next slide. Now we need to work out the turning point. To work out the turning point, we rely on a bit of symmetry. So for the turning point is basically halfway between the x-intercepts, halfway between the x-intercepts, or more correctly, it's got x halfway between the x-intercepts. As far as the x coordinate is concerned. So, how do we do that? Halfway between x equals 5 and x equals -3. It's a slightly harder one. So we'll actually go and work out the average. To work out the average, we divide by 2. So 5 plus -3 over 2, which is basically 2 over 2, because 5 plus -3 is 5 take 3, which is 2 over 2, which is equal to 1. And then to work out y, we just use our equation. Y is always x squared in this particular question, minus 2x minus 15. So y will become 1 squared minus 2 times 1, take 15. So I get 1 minus 2, which is -1, take 15 is -16. So I've got x equals -1, y equals -16. Let's go into the next slide and plot the graph. And all we have left to do is to graph it. So we'll pop up our axes as straight as possible. Now we know that the y-intercept is -15, so we'll go and pop some suitable scale on. We'll go -5, -10, -15. And then I'll go and put on the point. We also know that our x-intercepts are at 5 and -3. So I'll just number them so we know what we're doing. So let's go now and draw these on. 5, -3, and then finally we'll put on our turning point, which is at 1, -16, which is a little bit below the other point. And then this will probably be roughly the shape of our curve. Coming. You can do a better job than me. Label the axes X and Y, and get the graph label to Y equals x squared, take 2x, take 15. To make your graph look better, it's possible to work out even more points. So you could, for instance, choose a point like, I'd probably pick points that are a little bit between the x-intercepts that aren't the turning point and points way out either side. So for instance, we could pick a point like -5, which we know is way out. We could pick a point like 7, which is way out on the other side, and we might pick a couple of other points that are between the turning points. So we might pick, for instance, 2, and we might pick -1, and then go and work out what the y's are. To work out what the y's are, you basically have to use the equation. So the equation would be for this one, -5 squared, take 2 times -5, take 15. So we're going to get something like -5 squared. Let me write this better as a 5. -5 squared, so 25. Take 2 times -5 is plus 10 because it's of the two negatives. Take 15, so I'm going to get 20 as my coordinate there. So I'll pop a 20 in there. To work out this one over here, I'm going to do this case 7 squared minus 2 times 7 minus 15, which is 49 minus 14 minus 15. 49 minus 14 is 34, take 15, and I end up, 35, take 15, and I end up with 20. So again, this is going to be 20. Notice a nice mirror image. Pop a 20 there. That leaves me with 2. So again, 2 squared minus 2 times 2 minus 15. I get 4 minus 4, take 15. So this one is going to be a bit like the y-intercept, the same value. In fact, there's going to be -15. We'll get -15 written there. Sorry about the writing. And then the final one I'll do up the top here. And we'll just go and work out what that one should be. -1 squared minus 2 times -1 equals 1 plus 2, which is -12. We'll get -12 written over here. And you could keep on going for other points to make your graph look good. Remembering all of the time in our thinking, we've got to remember that y is equal to x squared, take 2x, take 15. So we can, once we know what x is, we can always work out what y is. So that was what I was doing to do that one, or that one, or that one, or that one. So there you have it, in detail how to draw quadratic graphs. Remember, your graph might be upside down if the number, or what we call the coefficient, in front of the x squared is a negative number. Thank you.